So good day. For today's day, we are going to discuss what is normal distribution and standard or DZ score. So first, let's define what is the normal distribution. So what is normal distribution? Normal distribution, or simplified as normal curve, is a bell-shaped distribution which has important role in inferential statistics. It provides a graphical representation in statistical values that are needed in describing the characteristic of population as well as in making decisions. So it is most important probability distribution in statistics. Also, it refers to a continuous probability distribution described by the normal equation. So next, the properties of normal probability distribution. So first, the distribution curve is a bell shape. So as you can see in this board, it looks like this. Next, the curve is symmetrical about its center. So it means when we say symmetrical, it's like a mirror. What we see in right is the same in left. It's like this, guys. Let's yes. And third, the mean, median, and mode coincide on the center. So in the center, here, dito natin makikita ang mean, median, and mode. And fourth, the tail of the curve flattened out infinitely along the horizontal axis, always approaching the axis but never touching it. That is, the curve is asymptotic to the baseline. Means that, as you can see, this is our horizontal line, and this is our normal curve. Normal curve. They are meeting each other but never touch. Yun. And 5, the total area under the normal curve is equal to 1 or 100%. Means that in this side we have 0.50 and 0.50 to become a 1 or 100%. Or simplify, let's say we have a 50% here and 50% also here. So there are two factors that the graph of the normal distribution may depend on. So what is this? It is the mean and standard deviation. So let's define first the mean. It determines the location of the center of the bell-shaped curve. Those a change on the value of the mean shape of the graph of the normal curve on the right or on the left. So it's looks like this. If we have a low value, the curve will be done like this. And if we have a high value, the curve will be done like this. And now let's go for the standard deviation. So it determines the shape of the graph, particularly in height and width. So if we have a large standard deviation, our normal curve will be short and wide. It's look like this. The large value of standard deviation, it's look like this. It is a short and wide. Short curve and wide horizontal line. Next, if we have a small standard deviation, it will have a more skinny and taller curve. We have a taller curve and a skinnier horizontal line. It's like this guy. So next we have a standard Bernard curve. So what is standard Bernard curve? It is a normal probability distribution that has a mean square of 0 and a standard deviation of 1 mean. So it's like this, guys. I drew not first. This 0 will represent our mean, and these numbers 1, 2, 3, -1, -2, -3 represent our standard deviation, or the distance in how many standard deviation away from our mean. So this guy. Also, we have a empirical rule, or also called as 68, 95, and 99.7. This will be determining how many percent we have a what do you call the area away from our mean. So first, let's know how many area or how many standard deviation away from the mean is the 68. 68 are 1 away from our mean. So if 1 away from 1 to 0, also in this one for 0, this total will be 68. 68. 68. And for the 95, it's called 2 away from our mean. So 2 away. So let's start with number 2. 2 also in the side, because say that the normal distribution is symmetrical. So what we will do in the right, we'll do in left. So it has a total of 95%. Yes. And from last, the 99.7 was 3 standard deviation away from mean. So let's start in the 3. So 3, 1, 2, and 3. 1, 2.3. It has a total of 99.7. So it is a total of 99.7. So where is the 0.3? The 0.3 is in this area. These guys. Here. So we need to divide it by, as I said kanina, 0.3 is divided by 2, which is equal to 0.15. So in this area, we have 0.15 and 0.15. And the total of this is 100% or 1. So after knowing what is normal distribution and standard or z-score, let's have a example in how to find area using our z-table. So first, let's answer the number 1. Find the area that corresponds to z is equals to 3. So first, we need to use our z table. So let's see here in my paper. You can see this in this yellow bar. This is our z table value, and the number are correspond to the areas. So let's say the 3 here is equals to 0.119. This is the area. So how do we draw this as a normal curve? So if this is the 3, this area was corresponds or the distance of the standard deviation into our mean. And here is 1, 2. That's all. Second, we have a question. Find the area that corresponds to z is equals to 3.26. So in our table, you can see in this side, the 3.2, and we need to find the last number of the given value, which is 6. Intersection was 0.4992. So when we shade this is 3, and 3.26, let's say that this area was the 3.26. So all the area of this was represent as the distance of the standard deviation in our mean. Guys, after knowing how to use our z-score table, let's proceed to another question or problem solving. Proceed to the third question. So, a soda machine dispenser soda is 13 ounce cups. Tests show that the actual amount of soda dispensed is normally distributed with a mean of 12.5 oz and a standard deviation of 0.2 oz. What percent of cups will receive less than 12.25 oz of soda? So first, let's know what is the value of our z. So we need this formula. Zx equals x less mean over standard deviation. So z is equals x the 12.25 less the mean, which is the 12.5. 12.5 over the standard deviation of 0.2 equals, so if we less this, we can get and divide it by 0.2, the answer is 1.25. After knowing the answer, let's go to our z table or the z-score, then find where is the 1.25. So their intersection was 0.3944 equals 0.3944. So this is the value of our z-score. Next step we need to do is to less it by 0.5 because as you can see, this is 5%, 50% and 50%. And the question is, what percent? We need to find what percent. That's why we need to less it. So 0.5 plus 0.3944, we can get the answer of 0.1056. If you calculate, this is the answer. Then next, we need to multiply it by 100% so that we can get the percent or the answer. And the answer was 10.56%. So, as one thing, this is the answer, the percent. Therefore, 10.56% of the score of the score less than 11.25 oz. Yes. So if we are going to shade it, if let's say this is the 1.5. Let's say this area is the 1.25. All area going to the left are less than 12.25. So let's go to our fourth and last question. In a math test, the mean score is 43 and the standard deviation is 5. Assuming the scores are normally distributed, what percent of the score is A greater than 49 and B less than 50? So first, let's solve the greater than 49. Using the formula of z-score, um, in the problem, we have 49 stand for x and for the mean of 43, less and over 5 for the standard deviation, and we can have a 1.2. If we are going to see what is the value in this in our z score, this will have a 0.3849. Just see it in our guys z score if I'm right, but yeah, I'm right. This is the value of our z. And next we need to less it for 0.5, and we can get a 0.1151 or 11.51%. So therefore 11.51% of score are greater than 48. So I'm going to use this guys to draw a normal distribution. Okay. Say this is it, guys. This is our normal distribution, guys. And let's say this is 0 and 1, 2, 3. So next, this will know that this part was 50% and 50%. Let's say that the 1.2 is over here. 1.2. So all areas going to the right was greater than 49. Yes, guys. And for our last question, letter B, less than 50. So again, let's use our formula of the z-score. Z is equal to x less mean over its standard deviation. So 50 less 43, our mean, divide by 5, our standard deviation, and we can get this 1.6. And when we are going to see this in our z-score, we can get a 0.4452. And we need to add this by 0.05. 0.05. And we can have the answer of 0.9452 or 94.52%. Therefore, 94.52 of score are less than 50. If we are going to draw a normal distribution, this could be look like this, guys. So this is 1, and let's say this area was 1.6, and all this area going to the left side was greater than 50. Oh, less than 50. This area, guys. So this is a 94.52%. This area, guys. 94.